Okay, in this video I'm going to do an exponential decay problem, and what I'm going to do is I'm going to find the half-life of a substance. So in this case, remember the basic form of an exponential equation is a b to the t. We can equivalently write our base b as this value 1 plus r, where r represents the annual growth rate. Remember also that a represents the initial amount, t will be my variable, we'll let it stand for time. So in this problem, it says, suppose we have some radioactive ion, the mysterious radioactive ion X, and we know that this decays at a constant annual rate of 4%. We want to know what the half-life of the substance is. And again, the half-life is the amount of time required for the substance to decay to half of its original size. Okay, that's what a half-life is. So I know the general form of my equation is going to be the initial amount. Well, in this case, we don't have an initial amount given. We'll just call it r. Now, the rate in this case is actually, it decays at a rate of 4%. So that means that our annual growth rate is actually negative 0.04. Okay, so this is going to be our annual growth rate in this case. The negative indicating that it's decreasing by 4%. Okay, so here I would just simplify this down, and we would get 0.96 raised to the t power. So basically this formula is going to tell us the amount of the substance that remains after t years, okay, since it has an annual rate. So we want to know the half-life. Let's just assume the initial amount of our radioactive ion X. Suppose our initial amount of this radioactive ion is just 100 grams. The half-life is going to be the same no matter what amount you start with. We could do it generically in terms of A, but I like to use numbers because they make more sense to poor Patrick. Okay, so then, so now the problem that we're going to have to simply solve is, again, y is the amount after some time t. If we start with 100 grams, okay, so we still have our 0.96 raised to the t. Well, now if we want to have half of the original amount, well, half of 100 would simply be 50. Okay, so we start with an initial amount of 100, we end up with 50 grams. We want to know the time required to solve that. So this is now simply the equation that we're going to have to solve. So the first thing I would do is divide both sides by 100 by 100. 50 over 100 is 1/2 times 0.96 raised to the t power. And at this point you can use any logarithm that you want. Again, I'm just going to take the natural logarithm of both sides. That's what's going to allow us to solve for t. So we have 0.96 raised to the t power. And remember, the whole point again of using natural logarithms is that on the right side we can use this property that exponents come down as coefficients. So we're almost there at this point. Let me give myself a little more space. Okay, so now I'm simply going to divide both sides. ln of 0.96 is just some number, so I'm going to divide both sides by that. And on the left side, I still have ln of 1/2. On the right side, if I divide, I'll get ln of 0.96, and that's going to be our t value. Okay, that's going to tell us the number of years for a substance, this substance that we started with. It'll tell us how long it takes for that substance to decay into half. Okay, so let me compute this real quick here. Okay, so ln of 1/2, that's roughly equal to negative 0.69 .3147. That's good enough for me. We'll calculate ln of 0.96. So ln of 0.96 is the value negative 0.04 0.4082. And if we round it off, it looks like the next one's a 2 as well. And so now we're approximating, so I'll say t is approximately equal to that. So now let's just simplify it down real quick. 0.69314, sorry, wrong button. 0.693147. Let's divide that by 0.040822. I'm getting this to be roughly equal to 16.98 years. So it says if something decreases by 4% annually, it's going to take almost 17 years for that that substance to decay down to half of its original size. Okay. So, alright, I hope this example makes some sense, a little bit of exponential decay. Feel free to post questions and comments, and hopefully me or somebody else out there can help you out. Alright, good luck out there.